Good afternoon. This is Ravi Babu, Assistant Professor in IARE College. Today I am topicing system response in second module. In system response, we are going to seeing the pulse transfer function of the system with respect to zero order pole. Whereas in previous sections, we have discussed that one is the definition of the pulse transfer function and numerical examples of the pulse transfer function for different blocks, that is feed forward block, feedback block and open loop block. For these functions, we have seen the pulse transfer function. Now, I am applying at today class is, we are applying a zero order volt. That is, we are having the zero order volt device at the function of the with different blocks. So, now I am considering the zero order volt block diagram. Is that one is connected to the single block, that is G of S. Whereas this G of S is nothing but it is a one of the forward path function. For this one, I am connecting the zero order volt device block. So for this zero device block, I am taking the one pulse. So here R of S is the input. When we are going for the R of S is the input and we are having the zero order volt device. So the pulse transfer function is nothing but it is Y of Z by R of Z into these two blocks are in cascade connection. That is zero order device and G of S system is all in cascade connection. So here I am taking the G H of naught into G of Z. After that one, this function, for this function, I am applying the Z transform. Okay. So the given function is, zero order function is coming to as G H naught of S is into G of S. So what is the zero order volt equation? That is nothing but in previous section already we discussed that one is 1 minus e power of minus t by s. That is your zero order O device equation. Okay. So this part is going to be multiplied with G of S. Now apply the Z transform. When we are going to apply the Z transform, we are taking here mathematical expression as G of S by S. If you multiply this one into G of S, this G of S. So G of S by S minus e power of minus st by s into G of S. Now we are taking the for this function G of S by S terms and e power of minus st by s terms. For this one, I am taking the first of all G of S by S is I am taking the G1 of S, and for this one, if I apply the inverse Laplace, that is nothing but the G of S by S is coming to as G1 of t, GD. Okay, G1 of t. Coming for the second one, that is inverse Laplace transform of e power of minus st by s into G of S. For this one, inverse Laplace transform is nothing but G1 of t minus tau. So if want to take it for this one, that is e power of my second term. In this one, second term, for this one, Z transform is that is nothing but this Z transform of e power of minus st by s is nothing but it is a unit time delay. That's why it is coming to as Z of G1 of t minus t. Okay. If you multiply this one where t is the k into t. If you taking the mathematical expressions here, so we got the Z1 minus Z into G of S. Okay. Z minus Z1 into G of S. Substitute this one Z minus Z1. Sorry, Z inverse of Z into G of S by Z. Okay. Substitute this one. So what happened? We get the Z transform of this part, starting part G of S by S minus e power minus st by Gs. For this one, we are going to take the Z transform. So the G of S by S is nothing but G1 of Z we know, and it is e power minus a by t. A by t is nothing but Z minus terms of G of Z. Okay. So if you taking here G of Z is common, so we get the this is a function. So it is a transfer function of the first order, transfer function of the system with zero order word. Transfer function of the system with zero order word. Okay, so this is your transfer function of the zero order word. That is nothing but, if you take this one is like this, 1 minus z inverse nothing but 1 minus 1 by z, that equal to z minus 1 by z into g1 of z. If you take like this also. Now I am going to calculating the pulse transfer function of the system. That is, here I am taking the g of s equal to the system block. Transfer function is I am taking the for system performance block is I am taking 1 by 1 plus s. This one I am taking 1 by 1 plus s I am taking. So find out the pulse transfer function for this one. Okay. Generally, what is the formula for this one? You know, this forward block, this into this one. This is the transfer function. Okay. So first to find this value, g into g of h of this value. So it is coming to as 1 minus z inverse of z of gs by s. 1 minus z of z inverse of gs by s. Yes, already we see the formula. This is the formula. Pulse transfer function of the g order device formula. Okay. 1 minus z inverse of g1 of z. This one I am taking. So 1 minus z inverse of nothing but z minus 1 by z. Okay, z into. What is g of s? G of s is nothing but 1 by s plus 1 into s. Take path of actions here. Okay, for this one. If you take the path of actions, already I explained this path of action method. So a is coming to 1 and b is coming to minus 1. Okay, b is coming to minus 1. So what happened? Here, here it is minus. Okay, it is minus. So 1 by s is coming and minus 1 by s plus 1. Minus 1 by s plus 1. You got it. Apply the z transform here. So for this, if z is taking inside, so what happens? Z by z minus 1 minus z by z minus e power of minus 3. 1 minus z by minus y. So z minus 0.013 is coming. So e power of minus t value. So it is 1. Z minus 0.31. If you solve this one, we got the value as 0.621 by z minus 0.3679. 3679. So this is our pulse transfer function. But they are asking as the question, determine the pulse transfer function for the step response. They are asking for step response. Okay, they are asking for step response. That is nothing but, if you want to step response, nothing but, so it is what y of z by r of z equal to 0.621 by z minus 0.3679. Okay, this total part. Okay, the total part. Next, what is they asking? They are asking us for step response. Step response nothing but this part are we going to step input nothing but this is coming to here. So y of z equal to 0.621 by z minus 0.3679 into r of z. Into r of z. What is r of z? Z by z minus 1. Z by z minus 1. So step to this one. Do the mathematical calculations. So while doing this mathematical calculations, we got the value as v of z equal to z by 0.3679. Okay, this is what z transform of the y, this function, given function. Now, if you take this is y of k equal to 1 minus 0.3679. Okay, so y of k the function is the okay. This is your 1 minus 0.3679. 3679. Okay, coming for the third problem. Determine the pulse transfer function for step response for the following. It is completely no. Determine here. But in previous section only we take the z of s is the z by s plus 2. So what is happened to your feedback is given. So I am taking the unity feedback. See the final answer comparison also here. Okay, why? Because the system function is same in previous section, only forward path will be there. Now I am going to feedback path also. So what is the transfer function of this one? Generally that is g h naught into g of s by 1 plus g h naught into s into g of z. G of z. Okay, g of z. So this is your pulse transfer function. Now I am going to finding this value. So what happened? Basic formula 1 minus z inverse of, okay, 1 minus z inverse of z into 1 by s into s plus 1. S into s plus 1. So what happens this one? Z minus 1 by z. Okay. If you take here inverse is cancelled, going to be z by z minus 1 into z into this value. How can you find the A? A equal nothing but total function into, okay, total function into that value. So if you substitute A is equal to 0, so A value is getting a 5 and B are getting as 0.5. 0.5. So substitute this one into here, above equation. What happened? We got the z minus 1 by z into z into 0.5 by z s plus 0.1 by s plus 2 equal to 0.5 into, if you substitute this one, okay, z minus 1 by z, z minus 1 by z minus z minus 3. Okay, it is 3. So now what is the final answer? 0.5 into 1 minus, okay, z minus 1 by z power of minus 0. If you take the LCM and find out this one, we've got the final value as this one, 0.43235. Okay, and here the z value is 0. Z minus 0.1353. Okay, if you substitute this one, so what happened? Pulse transfer function. What happened? This value, this is here. Wait, this is pulse transfer function. G of h into no. So substitute this one value is here. This value by, it is your feedback, unit feedback, no? So this value by, okay, this value by 1 plus negative feedback. I think it is negative feedback. Yes, negative feedback. Okay, 1 plus the above value plus by, okay, the above value by z minus this value. Okay, so finally we got the 0.4325. 0.4325. This is your pulse transfer function for the, okay, feedback path function with unity feedback. Okay, okay. Tomorrow we will see the one more problems on this one. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.